In this video, we are going to talk about the hypothesis testing for the variance and standard deviation, okay? So, similar to the confidence interval for variance, and then after we find out the confidence interval for variance, we do take the square root, right? And then we find out the confidence interval for standard deviation. So here also for the hypothesis testing, we test for variance, okay? So we do not directly test for we do not directly test for the standard deviation. We test for variance, all right? Because the square of the standard deviation is the variance, okay? And again, to find out the critical values, we do not use calculator. To find out the critical chi-square values, we use table from chapter 7. Okay, guys, let us do some examples on how to find the critical chi-square values. So for alpha equals to 0.05 and n equals to 20. So since n is 20, degrees of freedom will be 19, right? N minus 1. We need to find out chi-square left, chi-square right for left and right tail and two-tail test. So we'll be considering all of those. Let us do for the chi-square left. How would the graph look like? Chi-square is not symmetric. It is a right tail test, right? So it is like, this is like the chi-square test. And what it says is, for the left tail test, that 0.05 will go to the left. So that is 0.05. So we denote this by chi-square L, chi-square left, right? We need to find out that value of the chi-square left. What is the left area? 0.05. So if you want to use the chi-square table, okay, to find out the chi-square left and chi-square right, you need the area right of that value. To find out this value, we need the area right of that. Since the left area is 5%, the right area is 0.95%, and the degrees of freedom is 19. So we look at the column of 95 and row of 19 on the chi-square table, okay? This is the chapter 7 chi-square table. So column of 95 and row of 19. Look at that. This is the row of 19. This is the column of 95. So 10.117. This is what the chi-square value, 10.117. Okay. So let us look at that value. Oh, is that a 117 or 997? So 19 degrees of freedom. And then this is 95 left tail. So 10.117, not 997. It is 10.117. Okay, that's what you get, chi-square left. Next, for the right, what we do again is we shade on the right side only. Okay, this is denoted by chi-square R, chi-square right. So the area is 0.05. So to find out the chi-square critical values, we always need the area right of that value that you want to find out. So area right of this 0.05. That means you look at the column of 0.05 and 19 degrees of freedom. Okay, 19 degrees of freedom and column of 0.05. Let us go to the table again. What do we get? So the table gives us, let us look at that. So 0.05 and then 19 degrees of freedom is basically 30.144, right? That's what 30.144. That's what we got. Chi-square right is 30.144. And finally, for the two-tail test, okay, for the two-tail test, we find the chi-square values. What we do is we need to draw like this, and then longer tail on the right side. So alpha half, because this is two tail, so you need to shade on both left tail and the right tail set, right? This value we call chi-square right, that boundary, and this boundary we call chi-square left. Okay, so to find out the chi-square, because this value is 0.0025, right? 0.025. Okay, so this area is 0.025. This area is 0.025, right? So to find out the chi-square right, what we do is you look at the column of 0.025, and then degrees of freedom is 19. Column of 0.025, and degrees of freedom is 19. 0.025 degrees of freedom is 19. You see that? This one is 32.852. You see that? 32.852. Look at that. This is chi-square right. Okay. To find out the chi-square left, what is the total area right of chi-square L? That boundary is This is 95%, 0.95, right? And this is 2.5%, so 97.5%, that is 0.975. So we need to look at 0.975, okay? 0.975. Okay, how do I do that? Is go to that and then do 0.975, column of 0.975, and then 19 degrees of freedom is 8.907. That's what you get, 8.907. You see that? That is the chi-square left. So this is how we find out the chi-square left and chi-square right using the calculator. Let us look at example number 2. It is similar, but I want to do a little bit change here because we cannot find out for 0.02 there is no table value. So I am just giving 0.01, okay? Alpha equals 0.01, n is 24. So the degrees of freedom will be 23, right? So for the left tail test, what we do is alpha is 0.01. Alpha is 0.01. So we need to shade only on the left side, right? 0.01 is somewhere here. So this value is chi-square left. Degrees of freedom is 23. So we look at the table with degrees of freedom 23. So 23 degrees of freedom, and column of what is the right area here? Since the left area is 0.01, right area is 0.99, right? So we need to look at the column of 0.99. Let us do that. 0.99, okay, and then 23 degrees of freedom. It's 10.196. You see that? 10.196. 23 degrees and 0.99 on the right area. So this is 10.196. 10.196. For this one, again, here also degrees of freedom is 23, right? So what you do again is you will set on the right, because this is the right tail test. 0.01 is on the right. We denote that by chi-square right? So here, to find out the chi-square right, we need the area right of that. That is 0.01. So we need to look at the column of 0.01. So column of 0.01 is here, right? 23 degrees of freedom is 41.638. Right? You see that? This is 41.638. So that value, this chi-square right value is 41.638. Okay? And for the two tail test, what you need to do is you need to divide that 0.01 into the two halves, because you have to set both halves. So 0.005, and this will be 0.005. This value we call, this boundary is called chi-square left. This boundary is called chi-square right. Okay? So look at the column of, for the chi-square right, look at the column of 0.005. And for chi-square left, the total is 100%. The outside shaded region is 1%. So 0.99% in the middle. 99% and 0.5% will be 0.99, 0.05%. And that is 0.995%, right? 0.005 is so this is 99%. This is 0.5%. Which is 0.005. So 99% plus 0.5% will be 99.5% for chi-square left. Okay. So let us look at that. That is 0.005, 23 degrees of freedom. Right area is 44.181. That is 44.181. And the other one is, we need to do the 0.995. For the chi-square left, the total right area is 0.995. This is 99%. This is 0.5%. The total is 0.995, 23 degrees of freedom, 9.262. That's what you get. So this value is equals to 9.262. So this is how we find out the critical left, critical right, and then both critical values for left tail, right tail, and two tail test. Now to test the hypothesis, all the steps are same. Only the difference is the value, the critical value, and the test value. Okay. So by the way, what we should do is we should make this is B. This is B and this is C. I mean, it does not matter, but it is easier if you do that. Okay. So first we find out the critical value. First we find out the test value, and then we will find out the critical value. Okay. So first we will do this test value here, and then we will do the critical value later on. Okay. Similarly here, this is the test value. This is already on the B is test value and C is the P value. Okay. Let us do go through these steps. For the steps, first you state the null and alternative hypothesis. On the null and alternative hypothesis, you always use variance sigma square equals to or less than or greater than or not equals to, whatever you want to use. This is for the null hypothesis. For the alternative, it will be either sigma square less than or greater than. If standard deviation is given, you will have to square that and then you test for sigma square or the variance, okay? And then for the critical value, we just find the critical value there on the left tail, right tail test. For the test statistic, this is the formula we use. We use T or chi-square is the notation for the test value. N is the sample size minus 1. S square is the sample variance. S square is sample variance. Sigma square is the population variance, which is given by the null hypothesis, okay? Like 80, whatever is given there, that will be the sigma square. S square is the variance for the sample. If sample is giving the sample standard deviation, you will have to square it here. That S is the sample standard deviation, okay? And decision is again if the test value, this test value falls in the critical region in part C, then we reject, otherwise we do not reject. Similarly on the p-value method, exactly the same thing. To find out the p-value though, we need to use the chi-square Cdf, area left, area right of the test value, and we need the degrees of freedom there, okay? We use that formula to find out the, see, if you want to find out the area left, you start with 0 because no values of the chi-square are negative. Smallest value of chi-square can be 0, so we start with 0, okay? You don't have to do the negative values there. And for the two-tailed test, you need to do 2 times the area right or 2 times the area left. Depends on where the test value falls. If it is small value, then it falls on the left. Otherwise, it falls on the right. And again, if p-value is less than alpha, we reject the null hypothesis. Otherwise, we do not reject the null hypothesis. Let us do one example, okay? A cigarette manufacturer wishes to test the claim, there is a claim, okay, that the variance of a non-nicotine content of its cigarette are 0.644. So what is sigma square? Variance is denoted by sigma square is 0.644. Nicotine content is measured in milligrams and assume that it is normally distributed, which is the assumption we need. A sample of 20, that means N is 20. Cigarettes has a standard deviation of 1 milligram. So S is 1. So what will be S square? We'll need S square. You don't have to write it here because the formula has S square thing there, right? So we don't need that. But S is 1. And what is alpha? Is 0.05. Is there enough evidence to reject the manufacturer's claim? What was the manufacturer's claim? It is equals to, right? So rejecting means not equals to. So what will be 0? So you will have, so it is two-tailed because there is no less than or greater than, two-tailed. And this is claim as well because it says claim. So this is claim. Okay. Let us look at all the steps with the traditional method. This is the claim here. H1 is not equals to because it is two-tailed. And the test statistics n-1 S square over sigma square. See what we are doing here. Sigma square is 0.644. That is given. We don't have to square it. But 1 should be square because that is just S is given. That's why we need to do S square. If you do that, we got 29.5031. If you use calculator there. N is 20. So n-1 is 19. Now, oh, this is using the p-value method, but we can use the critical value method, no problem. But sounds like a p-value method is easier for this, but we can do using the p-value method. I mean the critical value method. I can show you that. The critical value method. So for the p-value, for 19 degrees of freedom and chi-square is 29.5. This value is big, right? So it is toward the right end. Okay, so what we do next is we're going to find out the, since it is the two-tail, we do 2 times the area right of the test value, right? That's what we're doing. So this is, the test value is 29.5031. So we're going to find out the 2 times the area of that. Why 2 times? Because it is two-tail test. Let us go to the calculator. And what we do is go to the second and then vars and go there in number 8, I guess. There is chi-square Cdf. Hit enter. Hit enter, what is the lower bound? You want to find out the right area, right? Right area means lower bound will be that value. Right area of the test value means lower bound will be 29.5031. That is the lower bound. Upper bound will be, you can write 10 to the 10. 10 to the 10. And the degrees of freedom is 19, right? Because the n is 20. And if you paste it, this is the p-value you get. So the p-value is basically 0.0585. Okay, but it is 2 times. So let us do times 2. Times 2. I forgot to do times 2 at the beginning. But anyway, 0.1169. That's what you get. The p-value. Okay. But what is our alpha? Our alpha was 0.05, which is, this is actually bigger than alpha. Since p is greater than alpha, we reject the null hypothesis. Exactly the same idea. Okay. Suppose you want to do this problem by critical value method. So in number 3, you will do critical value. So alpha is 0.05, right? And degrees of freedom is 19. And then what is the tail? So 2-tailed. So how would you do that? Is you will do the right-tailed, because the chi-square distribution is right-tailed. Okay. So 0.025, because half of the alpha is 0.025. 0.025. So chi-square left and chi-square right. For chi-square right, you need to do the 0.025 and then 19 degrees of freedom, right? So if you do 0.025 and 19 degrees of freedom, what do you get? Is basically 32.852. So that is 32.852. So 32.852. And the other one is, so right area will be 0.95. This is, the middle one is 0.95, right? So 0.95, and this is 2.5. So the total right area from chi-square left is 97.5. So let's go to here and do the 97.5. That is 0.975 and 19 degrees of freedom. That is 8.907. You see that this value is 8.907. I'm using the critical value method to do this because I did here with the p-value method. So now look at this. Is 29.50 falls on the shaded region or not shaded region? It falls on not shaded region because anything bigger than 32 falls in the shaded region. Anything smaller than 8 falls in the shaded region. So this will fall somewhere here, right? 29.50. So since the test statistic fall in the does not fall in the critical region, then we do not reject the null hypothesis. That is exactly the same thing. And then you write the conclusion. Thus, there is not enough evidence to reject the manufacturer's claim that the variance of the nicotine content of the cigarette is 0.644. All right. So exactly the same way we do another example. But the one of the thing that I want to tell you here is there is no direct way to use calculator for the variance. Okay, there is no direct way to do that. All right, let us do example number 2. First of all, let us write down the given things. The standard deviation of the statistic score sigma is given 100. Okay, the variance is, oh, that is the both is given. This may not be given to you. If sigma is that 100, then sigma square of that is 10,000, right? So 10,000 is the variance. An instructor wishes to see if the variance of the 23 randomly selected student in her school is less than. So what is that? That will be sigma square less than 10,000, right? That is the claim, and that is the alternative hypothesis, because the null hypothesis is sigma square equals 10,000. The variance of 23 test score is 725. What does that mean? That means S square is 7225. Variance is the sample. That is 23 score is the sample. Is there enough evidence to support the claim? Do we support this or not? That's what it is saying. Okay, that is the alternative hypothesis. That the variance of the school in our school district is less than. Since it says less than, there is another evidence that it is alternative hypothesis, because it says, it doesn't say less or equals. If it says less or equals, that would be null hypothesis. But it says less than 10,000 at alpha equals to, this is alpha equals 0.05. Assume that the scores are normally distributed. Let's do that. So it is left-tailed, and alpha is 0.05, right? Let us do that. So what is H0? Number 1, H0 is sigma square equals to 10,000, right? And H1 is sigma square is less than 10,000. Okay. Number 2, what is the test value? T or chi square, we denote by that. N minus 1 S square divided by sigma square. What is N? N is given as 23, right? So that will be 22 times s square is 7225 divided by 10,000. That is sigma square, right? If you use calculator to do this, what do you get? You get 22 times 7225 divided by 10,000, right? That's what you get. You get 15.895. So 15.895. So this is left tail test. For the left tail test, you need to find out the area left of that, right? To find out the p-value. So let me do number 3 in 2 different ways. I will do p-value method. So I will do one. I think I want to do one thing is p-value method. So p-value method. And another thing I want to do is critical value method. So you don't have to do both ways in your test. Critical value method, okay? So here in the p-value method, what you want to do is you want to find out the area left of 15 point. By the way, let me write down this is not chi-square left. This is the 15.895 left of the test value. 15.895. Okay. What is the degrees of freedom? Degrees of freedom is 22, right? Degrees of freedom is 22. So how do I find out the area left of that? Is you do chi-square Cdf. Okay, let us do that. So let me clear everything. Go to the second and then vars. Go to number 8. So that is chi-square Cdf. Hit enter. What is the left area? Is 0. Left bound is 0 because it keeps going on the left, right? Left bound is 0. Right bound is 15.895. Degrees of freedom is 22, right? And hit paste. What do you get is 0.1789. That's what you get. So the p-value is 0.1. Is that 17? Yes, 1789. So 1789. That is the area left of that, which is also denoted by p-value. So is p-value greater than alpha or less than alpha? This p-value is basically greater than alpha. P is greater than alpha. So do not reject 80, and then you write the conclusion by hence there are not enough evidence to reject the what was the claim though. The standard deviation is this, and instead wishes to say I think it is the claim. Okay, so alternative hypothesis is the claim. So there are not enough evidence to support the claim, right? Or you can say there are enough evidence to we are not reject. So there are not enough evidence to support the claim, or there are enough evidence to support that the sigma square is 10,000. You can do that way. Okay, that's how you write down the conclusion. Let us do the critical value method. So it is alpha is 0.05, right? Left tailed. So what we do here is you draw the chi-square curve, which is little right tail, and left tail is like this. So we want to find out, so this is 0.05. So you need to find out chi-square L, right? Chi-square L. What is the right area? 0.95. Because the chi-square, if you want to use the calculator, not the calculator, if you want to use the table, you need the area right of that. So 0.95. So you need to look at the column of 0.95, okay? And then the row of, what is the degrees of freedom? 22. So row of, so row of 22 and column of 0.95. So that will be 12.338. So this is 12.338. So that value is 12.338. But do you think the test value falls in the shaded region? What is the test value? Is 15.895. Oh, 15.895 is bigger than 12 point, right? So because the chi-square curve starts from 0, okay? So and then it keeps increasing on the right side. So this is where the t or the chi-square falls, or t falls, that test value falls. So test value doesn't fall in the critical shaded region. So meaning since chi-square does not fall in the critical region, we do not reject, we do not reject the null hypothesis, right? We do not reject the H0. So hence there are not enough evidence to there are enough evidence, you can say there are enough evidence to reject the claim, right? Because we are not rejecting H0, means we are rejecting H1. So hence hence we will have the same conclusion on both sides. Hence there are enough evidence to reject H1 or the claim, right? All right, this is how we test the hypothesis for variance. All right, thank you guys.